Hi everyone and welcome to MM914 December 2019 exam. In this video we're going to be going over question 1a and 1b of the probability section of the exam. Remember that the exam is in two halves, probability and inference. There are 20 marks available for probability and 20 marks available for inference. So we'll first of all begin by looking at question 1. When a veterinary practice opens, the probability of any individual patient coming into the practice being a puppy is 0.16. Question 1a asks, what is the probability that the first puppy of the day is the fifth patient at the veterinary practice? State what distribution you are using. And secondly, question B, write down any two underlying assumptions associated with this probability distribution. Discuss whether or not the assumptions mentioned are likely to be valid. So we'll first of all start by answering question 1a. So if we reread question A, we can see that there are two sentences in this question. We have a calculation, the what is the probability, so we must do a mathematical statistical calculation. And then the second sentence, state what distribution you're using. You must state this to gain the final mark. So the calculation here is worth 2 marks and the distribution, stating the distribution, is worth 1 mark. However, it makes the most sense to state the distribution first, so we'll do that first. So the distribution here is the geometric distribution. Now you'll recall the geometric distribution has the random variable x, where x is the number of trials until first success. Now the special thing about this is it's a special case of the negative binomial distribution, so we would have also accepted the negative binomial distribution as the correct answer. In the negative binomial distribution, x is the number of trials until the rth success, so in this case r would be equal to 1. However, to keep the analysis simple and easier, we're going to continue the calculation using the geometric distribution. If you use the negative binomial distribution, you would still get the same answer as if you use the geometric. Okay, so what do we do now? Well, we turn to our formula sheets that we got in the exam and we write down the formula. So we're using the formula 1 minus p to the power of x minus 1 multiplied by p. From the question, we know that p is 0.16. And we're interested in the fifth patient, so that's x is 5. So we're interested in the probability that capital X is equal to 5. Then what we do is we slot those numbers into our formulation as so. And then what we do now is we just simply tidy that up as done here. 1 minus 0.16 is 0.84, 5 less 1 is 4, and then we finally do that calculation and we give our answer to 2 decimal places. Now you've not been asked how many places to give it to, so somewhere between 2 and 3 decimal places is suffice. And this is in bold, and that means we've got our final answer here for the question. Okay, moving on now. Question B. Write down any two underlying assumptions associated with this probability distribution. Discuss whether or not the assumptions mentioned are likely to be valid. So in this question, your assumptions must relate to the probability distribution chosen in 1a. So here, if you'd written down maybe the wrong distribution, for example, the Poisson, you still need to give the assumptions of the Poisson. You need to be consistently wrong. However, we are doing this correctly, so we know it is the geometric distribution. In or the negative binomial, any two underlying assumptions of those. So these assumptions, I'm not going to give them all, I'm going to give the easiest two, or what I believe to be the easiest two. These are, all trials are independent, all trials have the same probability of success. Now, a lot of people, when they sat this exam, they stopped there, and that would only warrant 1 mark. The second mark comes from the second sentence of this question, which says, discuss whether or not the assumptions mentioned are likely to be valid. And we can see here that I've put that in bold font. Now, what I've written here is only an example of what you could give. These questions the solutions are based on a case-by-case basis, so if you've written something that's not this, but is sensible, then you will be awarded merit. However, if you leave this blank or do not answer it, you will not receive any points. So what I've written is, the trials may not be independent, as people may bring in more than one animal to the vets, whether it's a dog or a cat. In this case, it's a puppies, because that's what we're dealing with here. So the trial may not be independent, as people may be bringing more than one puppy into the vets at the same time. Perhaps they've rescued or adopted siblings, dogs. Now, the probability of these animals coming into the vet surgery is not going to be constant. Sadly, there may be peaks where people receive gifts of puppies, which is not something I'm an advocate of. And there might be busy times such as Christmas or the January time where lots of people got a dog for Christmas and are having to bring it into the vets. Now, again, like I've said earlier, these solutions, particularly for this question, these discuss type questions, as long as you write something sensible, you probably will get the marks. It just needs to be written, and this is very important. Your answer must be written in the context of the question. So here we're talking about veterinary practices, we're talking about dogs, we're talking about puppies. Your answer must have these words in it. If it doesn't, then you're not going to get the marks, because it says discuss whether or not their assumptions are likely to be valid in this case. So you need to be really careful that your discussion relates back to the context, because stats is all about context. And with that, I'll sign off. Okay, thank you for listening, and there'll be another 2 videos on this past paper on the probability section. Okay, thank you, goodbye.